for this webinar with Steve Gompertz. Before we begin, a few housekeeping items. Only the panelists are displayed and heard, but we do want to hear from you. Please ask your questions throughout the presentation using the Q&A button on your Zoom panel, not the chat. If it's put in the chat, we won't see it, but we will see it if you put it in the Q&A button. And yes, both a recording link and the presentation slides will be shared as soon as possible after today's webinar. My name is Raquel Cloyd. I manage business development and partnerships here at Intellect. I'd like to introduce our speaker, Steve Gompertz. This is Steve's third time partnering with us on a webinar. If you missed his first presentation, Guerrilla Tactics for Quality Leaders, or last month's webinar on what quality auditors really want to see, you can find the replays to both of those at intellect.com. Steve has over 30 years of experience in quality and medical technology, including roles at Pelican Biothermal, Abbott, Boston Scientific, Medtronic, and more. He is an adjunct instructor at St. Cloud University in Minnesota, is a Society for Quality Assurance Distinguished Speaker, and an MFES Distinguished Engineer. We'll hear from Steve in just a second. I wanted to tell you a little bit about Intellect. We are an award-winning quality management and environmental health and safety software company built on a no-code platform and powered with a robust AI integration. We help companies to automate quality processes, make root cause analysis more efficient, and achieve their quality and compliance goals. Those goals include compliance with a number of regulations and standards, whether that be ISO, FDA, GXP, ITAR, OSHA, EPA, and more. Intellect can help you whether you're in manufacturing, logistics, medical device, aerospace, automotive, whatever your company is, we can help you to reduce operational risk, improve profitability, and increase revenue. We have over 30 pre-built QMS and EHS applications ready to use out of the box, or you can utilize our no-code platform to build out unlimited custom applications to meet any quality or operational need. If you'd like to see a demo of our QMS software, you can visit us at intellect.com or simply type in the word demo into the Q&A button on the Zoom panel, and one of our team will reach out to you as soon as possible after today's webinar. All right, Stephen, we'll hand it over to you.
Great. Thank you very much, Raquel. And hello to everybody. Great turnout again. We're at 484. It's great. So, without further ado, let's talk a little bit about the background here, right? I'm assuming that the majority of people on the call are quality professionals or related to quality in some way. And hopefully everybody understands that the way you improve your quality system, the way you avoid continually having to deal with the same problems over and over and over again, is by eliminating root causes. But I think that concept gets misconstrued as to what exactly do we mean by root cause, and then how do you actually get to true root cause as we go through here. Whoops, I'm going too far ahead here. Sorry. So the things we're going to talk about today is the first step in the process, which is the problem statement. I think we often just go blasting right by this because it seems pretty obvious. Oops, did I do that? Sorry about that. But it really requires quite a bit of attention in the process, that you've got to get the problem statement right. Because if you state the problem incorrectly, then everything else that follows is going to go down the wrong path, leading you to the wrong analysis, the wrong identification of something that's not really root cause, which means you're going to address the wrong problems, put in the wrong solutions, and then you're going to be surprised when the problem actually comes back at some point. And part of that is, so first is getting that problem statement correct, and then it's doing a really thorough investigation to understand what is truly the root cause. And then I'm going to talk about then, how to dip into your quality toolbox to use more than one tool to get the job done correctly. And I'll give you a kind of a home-based plumbing example to help shore that up. All right. I think Raquel mentioned about putting questions into the Q&A section. Normally I like to answer questions as we go, but with such a large crowd, we can't really do that. But we do have a poll question here to kind of kick things off. Kel, you want to cover that?
Yes, we would like to know what are your current go-to methods for root cause analysis. There'll be a poll launching, select any that apply. Some have a tried and true method that they, rely on most of the time. Others might use multiple tools to manage root cause analysis. So before we begin, we just want to get a sense of this group. What are your go-to methods for RCA? We'd love everyone to answer. So we're going to give it a few minutes. We've got about half of our attendees answering the poll question. We'll give it just a few more seconds, and then we'll share the results. All right. A few more coming in. Thank you, everyone. So it looks like the 5 whys are definitely number 1, followed by the fishbone Ishikawa diagram. If you are using, or smaller percentage using FMEA, design experiments, fault analysis, and then we have about 21% using multiple tools. Thank you.
Well, great. That helps put things into context with how people are approaching it today. And that the results actually don't surprise me. I often push for 5 whys. It's the simplest to teach. I will talk about it briefly. So it's not a surprise to see that that's kind of the go-to there. So let's talk about the idea of getting to root cause and the difficulties there. And I think most people are familiar with the Terminator movies and the storyline there. So I like this as a good root cause analysis example. Skynet, the evil computer system. Its problem is it's losing the war, right? The human beings are now gaining ground and fighting really hard, and so that's the problem. It needs to figure out, how do we not lose the war here? So then it needs to look at what are the right root causes, right? The obvious cause, or the apparent symptoms are, right, the rebel fighters that they're dealing with right now. Really addressing that doesn't help. That's what they're doing, right? Every day they go out, they put out new weapons. They send out their Terminator robots and other type of robots to take out the fighters, and more keep coming, and they just keep fighting, right? So then there's John Connor, who's leading the rebellion. And well, killing him is probably not going to solve the problem. He's a symptom, right? Because he's already inspired, all these rebel fighters to keep going after Skynet. And then they come out, they go, well, how did John get this way? Well, he learned it from his mother. Now, she's already dead at this point, but then they figure out, if we can go back in time and we can kill his mother, then she doesn't teach John. John doesn't inspire a rebellion. There, Sarah Connor is root cause. Okay. Is that right, though? It may seem like the right approach, and that's obviously what they tried to do. Is they tried to go back in time and take out Sarah Connor. And if you've watched the movies, one, they're not successful. Two, it wouldn't have mattered anyway, because, oops, I keep forgetting I got to click on this to make it go forward. Because actually, Sarah is not the root cause. Our indomitable human spirit is actually the root cause. And so killing her doesn't really do anything. This is the nature of the challenge in root causes. When you get back, the solutions often do get more difficult, but that's where the right solutions lie. So I'll keep that kind of idea. So sorry, somebody just pointed out there was a typo on the slide. Yeah, losing, not loosing the war. Thank you for that. We'll get that corrected in the final version that gets sent out. So as I said, right, the big challenge is getting the problem stated well, initially, because it drives where you're going to go. And as I said, it's often more difficult than it seems. We think this is an easy step, but what often happens is we get really focused on what we've observed. The apparent causes, our beliefs kick in, right? Biases kick in. And that's how we then go in and define the solution, define the problem. Or we like to jump ahead a few steps and start thinking about potential solutions based on our assumptions and our biases. And we write a problem statement that sounds more like a solution. And now we've sort of taken out all the analysis possibilities, and we're already driving people in a particular direction here. Or we're just stating it in a way that ultimately we're not going to be able to determine whether we succeeded, right? Something that's quantifiable, measurable, something that can be confirmed, because at the end of the day, that's what you need to know. Not just that you took action, but how do you know that action actually addressed the problem? So writing a good problem statement is that step in getting you to go in that direction. So just some quick examples, and these things I've actually seen, right? Are any of these actually good problem statements? Parts fail dimensional inspection. Well, that sounds like, a problem, but it's actually a reflection of what did we observe, not really what the problem is. And I'll give you an example of what a better one is in a second. I always use this one jokingly to say, well, if that's actually the problem, I know exactly how to solve this. Let's stop doing inspections, and then the parts won't fail it. And that's not the intent here, right? That indicates we're not looking in the right place. Equipment needs to be replaced. Well, that sounds more like a solution based on an assumption. Inventory levels are too low. Okay, maybe that's part of it, but I think there's something more behind that we're not fully understanding by writing a better problem statement. So to rewrite those, right, for the first one, rather than focusing on the act of inspecting, the problem is the inspection is uncovering that 20% of our parts exceed their outer dimensional tolerances and assembly as designed. That's the problem. The parts are the problem, not the inspection, right? So you've got to make sure you're focusing in the right place there. For the second one, equipment does not start up when the power button is pushed. Okay, we're back to understanding what actually happened rather than jumping to an assumption and a conclusion. Maybe the power cord got pulled out. Maybe the circuit breaker blew, right? Doesn't mean we need a new piece of equipment because it won't start up, right? But then these kind of assumptions do happen quite a bit and drive us in the wrong directions. And then for the inventory one, the actual problem is that our production line is down an average of 20 minutes per day waiting for materials. Okay, now we understand something that has impact, and now we can start to trace that back to, so what causes that to happen? Could it be that inventory levels are too low? Possibly, but right now that's an assumption, and we don't know for sure yet. So we don't want to make that our problem statement. Okay. So again, you have to stay focused when you're doing this. A tool I like to bring out of the toolbox at this point, before anything else, is an is not matrix or a Kepner-Trago PSDM. I'll show an example here in a second if you're not familiar with those. We want to scope the problem, right? And as it sounds, right, what is the problem related to and what is it not? Are there things we can just eliminate? So it helps us set priorities and get focused, set some guardrails on this, and not get distracted. Right? There's always that one person who's got to throw something in, weird that seems like a tangent, right? And then it throws all the focus off of where you really should be, and then you don't plan the right next steps and so on. Brainstorming, right? Brainstorming is an actual formal quality tool if you're not familiar with that. And there are rules for how to use it that often don't get applied. And, some people hate brainstorming because it's just a mass of opinions and all this stuff goes out. If you do an is not first, you get to constrain that discussion, that brainstorming discussion. So that you get an idea of, are we deviating from the topic? Are we focusing on how does this problem occur? Do we understand timing of it? But we get to constrain the brainstorming into things that will help us understand the problem and therefore understand what the root causes might be. It also, this is not helps you figure out, are we missing anything, any differences that are subtle that we otherwise, wouldn't have paid attention to. And have we figured out when, I talked about timing already, when did it happen and exactly what was the nature of what changes might have occurred that may have contributed to this. It's a very simple tool for the most part, right? It's an easy thing to do in a matrix form, right? Two columns. One is sort of what is the context you want to talk about, and what is it and what isn't it. This is the start of our plumbing problem, right? So literally this happened in my house. My son came down one morning and said, "Dad, there's no water coming out of the faucet in my bathroom." Okay, now I need to figure out what's going on there. And so what I quickly do in my head, I didn't go fill out and it is not diagram, but we do this in everyday thinking, right? I start confirming what's actually going on. Is it just that faucet, or is it other faucets, the toilets, showers, anything that's using water? And I can quickly confirm it's only that faucet. So now I know when I'm going to be thinking about my, root cause analysis and the solution, it's just focused on that one faucet. Where is that? It's in one bathroom. It is not in any of the other bathrooms or any other places where water gets used. How about when? A time dependency. It's always. right? So it's not time dependent. It's not morning, noon, or night, or something like that. It's blocked. It doesn't produce water. It doesn't, regardless of when the timing is. And then who can make it happen? Well, it turns out it's everybody. So I can't blame it on the kids. I can't blame it on my wife, the dogs, whatever, right? It's for everybody. So it's not operator dependent. We know that now. And then to what degree? And is it reduced water flow or no water flow? Well, it turns out it is no water flow. It is a complete blockage of water somewhere in the system related to that particular faucet. So now I have a much better idea of the problem and things I don't need to even think about. Don't waste time on these. And now focus in on, well, here's what I want to do moving forward. All right, let's keep going here. So now once I have that, then that lets me say, all right, now I know what the problem is. Now I have a really clear statement and everybody can focus in on this. And now I can do my investigation because I know where, everybody needs to be paying attention. So as part of that investigation, we need to go past what's observed. Right? You need to think about, is this the only occurrence of what we're observing? Can we find it in other similar processes? Kind of like when I went around to the other faucets, right? I went to go check similar processes. Does it occur in different processes? And that's where I look at things like, excuse me, the washing machine to see, is it getting water, right? Different process, but based on water. And then, when did this start occurring? Okay, it was working last night when the kids went to bed and brushed their teeth. And then this morning, all of a sudden, it's a problem. Okay. But I'm getting to, understanding the full scope of the problem. First, I constrained it. Now I'm saying within those constraints, how far might this extend? In your own work, is it happening at another site? Is it happening in another work cell? Is it dependent on shifts, right? Things like that. You're starting to get a better understanding of what exactly is the observation rather than just the one thing we've already observed. The more information you can gather, the better your results. Data is better than observations. So we'll talk about, experimenting and trying to reproduce things and see if can I make it, which is a way of testing your theories there. But, don't just go with the minimal information that was observed. You want to build on that. Part of the investigation is first shore up the data that we're going to rely on to complete our investigation. And as I already talked about, right, this could be how you confirm that problem definition, right? We hopefully put more work into the problem definition. You want to test that definition by going out and going, well, let's run some tests on some things and confirm that we actually did state the problem correctly. It's similar to in the scientific method, right? First, you come up with a hypothesis, then you have to test your hypothesis before you go much further. So it is the same approach and thinking there. Don't just go, oh, that sounds great. Groupthink, everybody agrees that's the problem. Then let's go down that path. All right, go prove something, right? The old saying, in God we trust, all others bring data. It's that kind of thinking that you need here. All right. So now we've confirmed our problem statement. We've got lots of good data, and now we can do our analysis from here. So there are two types of causes we're concerned with. I call those observations, those symptoms, the apparent cause. It's the most obvious factor leading to an event. And it's usually wrong, right, in terms of root cause analysis, because it is things like the symptoms, our assumptions, our biases, our beliefs, right? What we just build in. We saw something, we make an assessment in our head and decide something. The test here is just quick. So what would I do about it? Right? And would those actions actually result in a long-term prevention of the recurrence? I come across a leaking pipe in the factory. I could tape it up, right? But I'm not focused in the right place, right? I'm making an assumption of, oh, the problem is the leak. So if I just keep water from coming out of the pipe, all is good. Well, how long is a patch going to last, right? And why is it leaking, right? We're not starting to think kind of 5 whys approach. We're not really thinking deeper than this. So you want to get past those observations and get to the root cause. And again, you need to think of it as a chain of events. Something led up to what you're observing. And you need to get back far enough in the chain of events, similar to the Skynet problem, where if I eliminate the correct root cause, none of the rest of the sequence of events can occur, right? We've chopped it off kind of at the head or whatever, however you want to think about it. But we're trying to find that point where I take an action on that and all the rest goes away. I don't need to take multiple actions. I'm not constantly revisiting this problem. It's not coming back. So we're getting past the symptoms. As I talked about, in the Skynet example, sometimes you can go too deep and you go back and suddenly you go, geez, that's something I can't do anything about. Right? Maybe, all right, let's step it back up a notch, in our 5 whys levels and go, where is something that's actually actionable? Because there are things that may not be within our control, although that could be telling in how we're going to have to address this and maybe monitor. But watch for going too deep, and then everybody struggles to go, well, what exactly would we do about that if that's actually where the root cause lies? I always like to call them root causes rather than just finding a root cause. Because I find it isn't, life is never perfect enough that there's usually one point, one single thing that if I address that, that's it. Every once in a while, but I often find that there's kind of a combination of things that of triggers that have to happen to get us to have the actual, whatever's bad happen at the end. Two versions of that. You could have independent root causes, which means that any one of those triggers can create the problem, right? That's the tougher one because now if you miss one, then the problem is still going to happen. So you might correctly find one of the triggers and address it correctly, and then you're surprised when the problem comes back, right? That your thinking could be either we didn't find the true root cause or there was another one that we missed. The other then version of that is where it's dependent. So the triggers all have to happen together, right? So the first one's kind of like more like an or function. The second one's more like an and function. But you still want to know that this is how it happened. When these three things happen at the same time, then we get the problem. The good news is that means even if you only get one of them, you should eliminate the problem, but I'd want to know, right? What were the other triggers that contributed to this? So you always need to expand your thinking that, there may be more than one cause at the root that's actually causing, whatever the problem is that we're having. All right, so these are some, good ones, and I'm sure people are going to be familiar with some of these that have shown up in your CAPAs or your investigations as, the final assessment of root cause. And there's our favorite, right? It's always the user, it's always the operator error. Okay. I'm not going to open it up, obviously, because we got around 600 people here, so we get quite an input. But the problem there is, the operator is right is a symptom, right? It's what we observed. Again, applying that 5 whys thinking right away, you go, well, why did they make the error? Why were they able to make the error? There's a whole bunch of questions that come there, and retraining the operator, firing the operator is not going to cause, mean it's not going to happen again, right? So that one's always a cop out to just go blame it on the person that was standing there when we had the observation. Similarly, equipment failure. Okay, let's not blame it on a person. Let's blame it on a thing. It's the same problem. I want to understand why did the equipment fail, and is that actually the main contributor to the problem, or is there something else going on there? Lack of training, right? Oh, yeah, just retrain everybody. I already talked about that. It's usually tightly aligned with operator error. Again, not a great root cause because it might not be a lack of training because, you look at training, this goes, well, all the operators are trained. They were trained recently, not too long ago, and they're up to date on the versions of the work instructions. So maybe it's not lack of training. Maybe it's the quality of the training. Okay, that might make more sense. Or is the process untrainable? Has to come to mind here, right? You could train them every day, and that process is so horrid, you're not going to get good results. I had a process at a place where our first pass yields, no kidding, were in the low 30% range. That's incredibly bad. And we spent a lot of time, of course, looking at, the operator's not doing the right thing. Are they performing the task incorrectly? And then we found, as often happens, the problem was actually much earlier in the process before it even got to those operators. And the process was the problem, and there was no way to train them to do their step any better because we were already setting them up for failure earlier in the process. Change of conditions. Oh, yeah. We got surprised because it was more humid out for a week than we expected, or hotter, or whatever, right? Or, water pressure was down. That's kind of a cop out to just say, yeah, I guess things change every once in a while, and when they do, we're going to have problems. Where was your initial design and process validation where you consider, like design of experiments? What are all the variables, and how likely are they change? What are the probabilities? It just says that actually your process of creating this process is probably suspect. It's not the process itself. Well, it is the process, right? The process is not sufficient, but there's a question about how you designed your process in the first place. What kind of validation did you do? Is there, shortcoming in your validation? It says there's a problem somewhere else rather than just a cop-out statement of, yeah, well, conditions change and I guess we'll deal with it when it happens, right? Well, what if it was something really severe that happened? I don't think you want to allow for that. I've seen this one. Oh, yeah, we missed a requirement in the document, right? And then the corrective action, as it will be called, will be we updated the document. Okay, that's a correction, not a corrective action, if you're not familiar with those terms. A correction just means I fix the observed condition. Doesn't mean I set up anything that's going to prevent it from happening, right? I want to know, well, how did we miss that requirement? Where do we normally check that? What's our process for reviewing document content? How did we end up with a document that was missing things that apparently are important, right? That's where I want to focus my attention. And then another favorite of mine, failure of imagination, right? One, I would find this pretty insulting in the organization because it implies we weren't smart enough to figure this out. But often it's just, again, it's pointing to we got lazy early on and we didn't really do our jobs correctly. The two places that's in quotes because it came out in two very high profile situations in the analysis. One was the Shuttle Challenger explosion, and the other was 9/11. And both of those, the investigation committees actually said, yeah, it was a failure of imagination. And ultimately, it was proven in both cases they were wrong. They didn't know about these possibilities in both of those cases. All right. So I'm going to pause again with a poll question, Raquel.
Yes. So we'd like to know what tools you're using now to conduct root cause analysis. Our poll is launching. Choose all that apply. And maybe you're using pretty manual methods like Post-its and whiteboards or forms. Maybe you're using spreadsheets. Maybe you have a QMS software in place that has root cause analysis functionality. Maybe multiple ways to manage root cause analysis. We'd love to hear from you what you're currently using, and would love it again if everybody could participate. We'll give it another 30 seconds or so. We've got about a little more than half of the attendees. I know I've seen some comments in the chat about different methods as well, so maybe an other would have applied there. All right, let's go ahead and see where we're at. And we'll share the results. Looks like a lot of people, the majority are using company forms, so that's the most popular, followed by spreadsheets, some still very manual Post-its and whiteboards, and about less than a third are using QMS software. So thanks everyone for sharing.
Yeah, very, very interesting. But yeah, everybody loves a good form, right? So it doesn't surprise me there either. And there's nothing wrong with that, as long as it's a form with the right tool at the right time with the right information. So yeah, so let's talk about tools here. So as was apparently most popular, go-to tool, the 5 whys. It certainly is a useful tool. As I talked about, I usually introduce it in places that are not using any sort of tools because it's so easy, right, to teach and apply. And the concept is, right, you think like a 3-year-old, you pose the problem statement, why did that happen? You answer it, why did that happen? You answer it right, and you keep going. I just like to point out you don't have to get to 5. Sometimes you can get to the root cause in less than 5 questions. Sometimes it takes more than 5 questions. But as I said, very easy to teach. The problem is that it's not really well designed to focus on that possibility that there's multiple root cause. Oftentimes we get very focused on one pathway through the 5 whys, forgetting that sometimes when we ask a why, there are multiple answers to that. And then each of those should branch into another set of why questions. But it gets kind of convoluted then and tough to manage at that point. But I'll show an example on the next slide. The fishbone diagram, Ishikawa diagram. So a lot of people seem to like this. And I can see one person in the Q&A has kind of started to refer to man, machine, methods, that kind of stuff, which is part of the the approach under the fishbone diagram. Um, so it's nice because it makes you see the problem from multiple perspectives, which then hopefully gets you thinking about the possibility that there are multiple root causes. So I think, that's what's really powerful. It's kind of why, Ishikawa created it, was to get that thinking to happen more broadly. The challenge is it can't be your only tool, and I'll talk about that in an example. It has to be fed and checked by other tools. Right? You'll hear this as a common theme with me, that if everybody probably knows this phrase, right? If the only tool you have is a hammer, every job starts to look like a nail. You need to avoid that thinking. As quality professionals, we should have a full toolbox and know how to use all those tools in conjunction. Then I usually tell people, think of the last repair job you had. Do you have any time that you were able to do it with a single tool? Probably not often. Okay. Maybe if you had to tighten a screw, great, one tool. But most, repair jobs, you are bringing in multiple tools here. Brainstorming, as I already talked about, is an actual formal quality tool, and you should learn how to use it correctly. It's not just the Wild West. Everybody shouts, and somebody who has the strongest personality tends to monopolize. There are ways to actually perform really effective brainstorming. It has that advantage of then it generates a lot of information very quickly. But as we talked about, with the is not, it can go off the rails, right? And suddenly the reason you're generating so much information is because it's stuff that's not really relevant. People have agendas, or they just get confused or get distracted. And again, that's why it's good to understand the actual way to do effective brainstorming rather than just making it a free for all. And again, that best practice is use all of them. Right? You have a toolbox full of tools. Hopefully you understand how to use those tools, which then should lead you to, then I should be able to, apply them together to produce a much better outcome. So let's take a look at that 5 whys real quick. If you're not familiar with it, it's, as I said, you start with the problem statement and just keep asking why, right, to every answer. It often gets depicted this way. As I said, we kind of get this single pathway. So again, I'll use my bathroom faucet problem. The problem statement is there's no water coming from the bathroom faucet. Why? And here's where bias crept in. My first thought was the kids were playing with the valves underneath the sink and they shut them off. That's why no water's coming out, right? Why are the valves closed? Because the kids are playing with them. Why are they playing with them? Well, it's not like I ever explained to them what they are, right? So they see something and they touch it and they mess with it, right? Okay, that sounds like I got to teach them. Hey, kids, I want you to look at this. Don't mess with these because this shuts the water off. And then when I get under the sink, turns out they're open. That's not the problem. I missed a pathway in here somewhere, right? Which is why I said you need to think about that there might be multiple answers. And so rather than thinking of this sort of waterfall hierarchy when you're doing a 5 whys, think of it as a logic tree that has to branch, right? And like I said, one of the branches was that valve shut off, but the other is, well, wait, maybe there's a clog. The filter or something else is clogged. And now I can lead to other whys, some of which will also branch, and start thinking about, do I have multiple, things I need to address here in terms of corrective actions? All right, see a lot of thumbs up floating here, and claps, so this must resonate with people. All right, so let's talk about that Ishikawa fishbone cause and effect, whatever your favorite name. If you're not familiar with Karo Ishikawa, there's a picture of him. Looks like a fun guy, but he had a lot of really good ideas, right? And his approach was to say, look, if we have this problem, we need to see it from different perspectives, right? Whoops, I went the wrong direction there. Um, so that you don't get hung up on the most obvious cause or the bias or the groupthink, right? It makes you, take a look at things from different perspectives. I don't know, everybody remember the movie? I love movie references. You might figure this out. The Dead Poet Society, where Robin Williams makes his students stand on top of their desks because then they see the room differently. That's kind of the same approach that Ishikawa was going for. Stand on the desk, turn around, face a different direction, see the problem from multiple angles, and learn more about it. And then hopefully, get to a better, root cause and therefore better solutions for that. So that's what I was just talking about. The common approach, and this is what Ishikawa, went with, was what he called the 6 M's: materials, man, methods, machines, measurements, mother nature. We've changed some of that over the years, right? So materials is, about components, consumables, or information. Man is meaning personnel. Methods is process. Machines, equipment, and tools. Measurements gets the data. Mother nature meaning the environment in which things are happening and its ability to impact things. So that was the basic concept. But there's no rule that says you must do it this way. But this is sort of a generalized version of what it looks like with the 6 M's, or their the current terminology used for that. And you get a sense for, right, that we have some sort of quality problem, and when you look at it from the perspective of the machines involved, the equipment involved, then you get these possibilities. Is the machine out of adjustment? Is there a tooling problem? Is it just a old and worn out machine? Right? It starts going, all right, and then you jump to, oh, let's look at the process, right? Stand on the desk, look in a different direction. And now we see maybe the process is poorly designed, as I was talking about earlier. Maybe we're just not managing the process well. Or maybe it's the product going through the process, right? The root cause is even further back than we thought. It's not the process at all. It's that the design doesn't really match well with how we're going to process it, right? And so the design makes it impossible to have an effective process. So this is the idea behind this. I just throw this one up as an example of, right, you don't have to use the 6 M's. I found this one online. It was for a trucking company. And it just shows, right, this one's got 7 bones, as we might call them. And it shows that they had a better understanding of the things that they felt were the factors that go into their transport process. And so they analyze the problems from that perspective, right? Because they say, we understand our environment really well. Here's the 7 things we want you to consider when we're addressing problems there. So I thought that was a really good view of the other ways you can use it, right? You can have 3 bones, 5 bones, 6 bones, 10 bones, whatever makes sense for type of problem or your type of business. So, as I said, you've got to dip into your toolbox and use them together. And here's an example. This isn't the only way to do it, but this is one I frequently use when I'm brought in to look at these problems. As again, I like to start with that is not. Get everybody on the same page of understanding, right? And then we can define a much better problem statement. Now everybody's focused, right? We don't get all those people with their agendas or their weird ideas that are going to distract. We get everybody focused on what we need to focus on. Then build a fishbone diagram for this. All right. Now that we have a good problem statement, let's make that the head of our fish, and let's build our bones. 6 M's is usually a good way to start if you don't have enough understanding of the environment. Ishikawa got that part right. And then you go through each bone, and this is where brainstorming kicks in. Right now, all right, we're only going to talk about the effect of equipment on the problem statement, right? So now let's do our roundtable. Let's use the correct rules of brainstorming, one idea at a time. You don't get to just shout. Nobody gets to monopolize, right? We don't debate. We just capture, right? And now we go through. All right, we've talked about. Are we done? We're done talking about the machines. Great. Let's go talk about process. Exhaust all the possibilities there through brainstorming. Move on to the next bone, right? So it's really 6 brainstorming exercises there. Now, let's take a look at what we got, right? Now we've got a fleshed out fishbone diagram. And now we need to start experimenting, right? Confirming some of these hypotheses. So we want to start going in. Well, can we confirm any of these things that are showing up? Can we confirm whether or not the machine is out of tolerance, out of calibration? Yeah, that's something. Hey, has anybody gone down to look? Is the calibration overdue? Is there anything indicating that maybe it is out of calibration and we should have somebody recalibrate it? These are some simple things that just go, is that a factor or not a factor? And you start to eliminate things. It's almost kind of like repeating or refining the is not, right? Because now you've added some things that are more detailed, but you've gone down to confirm them and say, are they actually still part of the investigation, or can we discount that? Then you start going, all right, you still may have a lot of choices here. You can't, as we say, boil the ocean. You're not going to solve world peace here. But can we get an agreement? And this could be a brainstorming exercise again, but at least some sort of agreement. There's also other tools that'll help you kind of get to consensus that I don't have time to go into today. But you want to get down to which are the ones we want to target first, right? We have to set priorities. We don't have unlimited resources. So All right, based on where we are and what we've constrained it to now, what are the things we want to focus on first? Let's pick the top three and go after that, right? Maybe it's 80-20 kind of thinking, Pareto thinking, right? Where do we think the most impact may be coming from based on best expert, analysis or assessment from here? And then now let's take each of those three and now do our 5 whys on them. Okay, let's really dig deep. Find out what do we think was triggering that part of the fishbone diagram, right? And then that's essentially adding more bones is what it may look like. But remember that the bones can branch, right? As I said, the 5 whys should as well. All right, great. So now we think we understand. We've got our main candidates. We've drilled down into those, and we think we understand the root causes. We're going to be looking for. Did they all drill down to the same root cause? Because that would be just wonderful, right? That it turns out those three are actually looking, and they all can be addressed by one thing. But again, watch for where actually. Oh, look, there are multiple triggers here. Then more confirmation. All right, so now we have our hypothesis. We think these are the one or two things that cause this problem to happen. All right, before we go brainstorm on how to solve that problem, again, more confirmation. Let's go test that theory, prove the hypothesis like we did in the scientific method. So, can we do some additional monitoring or do we have some existing monitoring? Can we experiment? Can we see if we can make it happen? Can we simulate? Can we just do some additional testing, to give us more data? I think we all know there's ways in which we can confirm this and we should do it. The obvious one is, all right, if that's the trigger, let's try pulling that trigger and see if it actually happens as a result. Now, sometimes that's not a viable option, right? If it leads to something really bad, like a fire, an explosion, you obviously don't want to have that happen again. But that's where maybe simulation comes in, or other ways to emulate what's going on to prove that our hypothesis is actually correct. Ignore all those apparent causes, all the earlier part of your 5 whys. Just go to the last one, right? Because again, if you get the right root cause, all the others disappear. They're not important. John Connor goes away. The rebellion goes away, right? If you get Sarah Connor is the thinking. So just focus in your efforts, your resources on confirming the hypothesis around the root cause. Because if you confirm that, then you can feel confident that the apparent causes will be taken care of. So as I already talked about here, right? Then there's, obviously the best is if you can recreate the problem by triggering the root causes. But if that doesn't work, now what? Does that mean we got it wrong? It maybe, right? And you want to look at, well, maybe we're still looking at an apparent cause. We haven't gone deep enough yet in our 5 whys thinking, our investigation. Again, maybe it's not the sole root cause. As I said, maybe there's another one and we just haven't found that yet. Or that it has to happen in conjunction with other things, right? Other triggers. Or maybe we got to go back and go, are we actually following the right problem here? Did we maybe misstate the problem? And that's why we're getting to something that doesn't seem to actually be related to what we're actually observing. All right, so let's go back to my clogged faucet. Let's apply this process to that. Okay. So I'd already done my is not. Okay. And I know that there's no water coming out of, and I could probably be more specific, the kids' bathroom faucet, right? So that I can strain the problem here. All right. Then I throw my bones on here and I brainstorm each of them. And I look at methods and I go, it's got both hot and cold water handles on the faucet. So I'm going to look at those as two different processes, right? I'm going to look at my materials. I have the water coming in from the city and I have water softener salt as a material. Remember, I'm brainstorming, I'm not judging yet, okay? Or not debating. My environment, it's city water. I don't have a well, right? So my water comes from the city. In terms of measurements, well, there is a water meter on the house. So that's a form of measurement in the process. So yeah, let's keep that in the mix for the moment. And then who are the people involved? As I mentioned, what's the kids' bathroom of the kids? My wife goes in there, and the city Department of Public Works provides the water, right? So those are my people. And then my machines, there's the faucet, there's the valves under the sink, there's the water pipes going through the house, and there's that water softener, right, that I want to consider. So now I have a broader picture, right, of the variables from different perspectives so I didn't miss anything here, at least not yet. As I refine some of this, I might find some things I didn't think about, but now I have a better picture, right, the total picture of what I'm going to look at. So then next is, as I said, all right, let's start checking some of this stuff out. Let's start confirming this. Can any of these be considered non-factors that we can immediately jump? Well, it doesn't matter which handle I turn, cold or hot, no water comes out. So it's not related to the process. I understand how a water softener works. It's not the water softener salt, right? It's because it's one faucet, right, with no water coming out. The water softener and the water softener salt can be eliminated at this point. The water meter. Other places, water is coming out just fine. The water meter is spinning when we use water. That's not a likely candidate, right? That doesn't seem to be playing any role in this. Water is getting into the house. And then I already had eliminated the valves underneath the sink, right? I said they're not a factor, they're on, they're open. So that doesn't seem to be an issue. And I've determined it doesn't matter who does it, the kids and the wife, right? But that leaves the city who's providing the water as somebody I still want to look at. Now, when I look at the faucet, and I said I've turned the handles, one thing I was able to observe is when I turn the cold and the hot faucet handles on, the hot handle feels hot and the cold handle feels cold. That means water is getting that far, right? That it's actually causing a temperature change in the handles. So it isn't the faucet as a whole that's an issue here, but let me think more deeply. The faucet does have some components. I've already talked about the handles, but it also has a filter that I didn't consider before. So I need to add the filter now to my possibilities here. Okay. So now I'm starting to get a better picture of things that are still in scope. By the way, the water pipes, I'm going to eliminate those because water is getting elsewhere in the house. And as I said, I can feel the temperature change at the handles. So water is getting through the pipes and all the way to the faucet. Right. So I can take those out of the equation. And now I'm left with this. I got the filter. I have the city and its water supply. All right, now I can dive in more deeply here. Right, so now start doing my 5 whys. Well, I want to investigate things. The first thing I said, well, let me investigate that filter and I'm going to take it off and take a look at it. And it turns out it is filled with sand. It is absolutely clogged completely with sand. I dump all the sand out, I rinse it, I put it back in, I turn the faucet handles on, and water comes out. Ha! Victory! Right? I've addressed the root cause, have I not? If I could see you, I'd hopefully see a lot of shaking heads. No, right? I have corrected the situation, but I have to now think more broadly, going, wait, where did the sand come from? Right? Where else is that going to cause a problem? Think more broadly than where I'm just observing here, right? Remember, I have other faucets, I have other things that use water in the house. I want to really understand where did that sand come from because that is where the root cause lies. Right? And then it dawns on me, we get these flyers from the city. Look around, by the way. Sorry, yeah, confirm scope. So I go around to the other faucets and I start taking out the filters, and every one of them has some sand in it. Oh man, okay. So this is a systemic issue. Okay. It just got worse case at this particular faucet. But now I understand the full breadth of this. My solution has to address the entire system here, right? So that's why it's important to get to the root cause, because that apparent cause of one clogged filter was not going to address that the others were going to fail at some point as well. So as I said, I started thinking, so where would sand come from? My system. And then it dawns on me, right? We get these periodic flyers from the city that says, twice a year they come out, say, by the way, we're going to be in your neighborhood flushing the fire hydrants. And you might see some discoloration in your water because we're disturbing the sediment in the system. Sediment, sand. That's where it's coming from. The city, when they do their biannual cleaning out of the fire hydrant system, are disturbing all this sand, which is getting into our water supply, getting trapped by the filters, because that's what they're supposed to do, so it doesn't get into us. There's my root cause, is that fire hydrant flushing. Okay, so great. Now I understand where the root cause is, but now it gets a little trickier. I don't have a slide on this, but from here now, at least we're focusing on the right thing. I can't go to the city and say, hey, stop that. I don't want you doing that anymore. Right? I can't have you flushing the hydrants because it messes with my water supply. But I need, now that I'm aware of it, and now I can do things that are kind of like preventive maintenance. I now know I have to go periodically clean out those filters. So I do that the same time of year when I replace all the smoke detector batteries. I go around and I unscrew all the filters and clean them out, right? So that they don't ever get enough sand to become blocked, right? So it's not quite the same as eliminating the root cause, because sometimes elimination is not probable, but I know how to manage it now. And I've put in place what I need to do to manage the situation. And then, it'd be a whole nother talk to talk about testing out those theories and putting in the right causes and confirming effectivity. But I think we get to it. But this is where I wanted to get to today, was broadening your thinking, figuring out, right, that, hey, these problems, don't occur. The root cause is often not at the point where I observe the problem. And I need to see the entire system regarding that. So anyway, that's what we're going to cover for today. I appreciate all the thumbs up that were going by. I see we do have some questions. We'll get to those in a second, but I really appreciate the turnout here.
All right, thank you so much, Steve. We will get to the Q&A in a few minutes. This would be a good time, if you haven't already asked your question, to put it into the Q&A button on your Zoom panel. Again, we won't see it if it's put into the chat. Your company might not be ready to take on a QMS, but perhaps you have a colleague or know of another company who would be interested in exploring Intellect. I wanted to share our Refer a Friend program. You can refer a company who might be interested in looking at our QMS and earn up to $5,000 if they become a customer of Intellect. There's a link at the bottom right portion of that slide, or on intellect.com. You can find it to submit a referral. Here is Steve's contact information if you'd like to get a hold of him, if you have further questions, you'd like to ask about his consulting services. We have a link to his email, his LinkedIn profile, or you can use the QR code to get in contact with Steve. I'd like to invite everyone for our upcoming webinars. Next month, we have a webinar on how to cut insurance costs by $150,000 with a QMS. So this is actually very interesting. A lot of insurance carriers will provide discounted policies and rates when you have a QMS in place. We have a manufacturing expert who has helped other companies do this, who's going to speak to this next month. So bring your quality, operations, and financial colleagues to that webinar. And I'd also like to invite you to our November conference, Innovate 2024. It's a virtual conference that we have every year. We are going to have our exec team talk about what's on the roadmap for Intellect for the next year and beyond. Steve will be back to join us with a really engaging speak on quality. And you'll be able to hear from some Intellect customers as well as how they're using the platform. So registration details will be online soon at intellect.com. Again, if you'd like to see a demo of our software, you can use the QR code there to schedule a demo. Visit us online at intellect.com, or just type the word demo into the Q&A button on your Zoom panel, and we will reach out to you ASAP. All right, we've got a few questions already lined up. All right, Steve. First question, which I'll actually take on the first part of it, but then I'm going to have you jump in. Can or has AI been applied to root cause analysis, or how far along is AI in root cause analysis and developing CAPAs? So Intellect actually has an AI integration. Our Intellect Smart Analysis provides predictive analytics and can help with things like root cause analysis and developing CAPAs. So if that is something that you'd like to see in more detail, again, type in demo into the Q&A portion of your Zoom panel, and we can get that information out to you. Steve, anything to contribute on the AI front?
Yeah, I think this kind of gets back to having good data, right? And so I think building it on top of a platform like Intellect, or anything else that's information gathering that you've got, is going to be important. You can't just log into ChatGPT and give it the problem statement and go, what do you think happened here? It doesn't have enough data to do that. It may give you some broader suggestions, but yeah, I'm sure various software vendors are starting to obviously adopt AI add-ons, into the functions in their system. And I think that's the key, right? Because if you've captured good quality data in your EQMS, then now the AI has something to learn from, right? And go, well, you know what? There are some hidden trends in here that might be contributing to this, those kind of things. So I don't know that it's proven out yet, but we're going to be going that direction. AI can be, quite a powerful friend. Forget about, the Skynet, those kind of things. Just understand AI will be the thing that will help you going forward to get answers quicker.
All right, thank you. Next question that relates to the 4Ms, 6Ms. If there are multiple root causes, doesn't that really mean that you have not drilled down far enough to truly identify the single root cause? It can be only one of 4 categories of root cause, and they name a few of the M's in there. Any feedback on that, Steve?
Yeah, I mean, I used to have the same kind of thought going, well, wait, if there are multiple, I've had people challenge me before going, it's root cause, singular, right? But the reality is the problem you're seeing, if you're familiar with risk management, and things like FMEA, uh, multiple hazardous situations can lead to the same exact harm. They are all very different situations. And that's the kind of thinking I'm talking about here. What you're observing in terms of the problem could be caused in multiple ways that are not related. And I think the fault is in thinking, no, we have to find the magic bullet that's going to solve all of this when realizing that type of observation, that type of failure could be created in multiple ways. And if we want the entire problem to go away, we need to find all of those hazardous situations or all of those sequence of events. So I think it is likely that you need to look beyond just a single magic approach to fixing things.
All right. Next question. I work in supplier quality, and a lot of vendor replies to scars are the bad root cause analysis examples that you shared. What is the best way to enforce better CAPA?
Education is the key. Um, you know, I think, again, I talked about earlier about quality of the training. Uh, you need to, whenever you're training people on tools, on processes, on anything, besides showing them the how, you need to explain the why, right? Why do we do it this way? What is the purpose of doing that activity in that particular way? And I think that's what's very common. We know CAPA, if you're in the medical device industry, CAPA is always the number one finding in FDA inspections. It has been for like 20 years. You sit there and go, why can't the industry figure this out? And I think it's not, just the medical device industry. I think you find that common in lots of industries. I see lots of posts on LinkedIn about this. And yeah, we try to oversimplify a process like CAPA, which is actually inherently difficult because it's supposed to focus on systemic issues. And we get too focused on treating it like it's the individual non-conformance system where maybe correction is all you need, right? And that's quick, that's easy, and everybody pats you on the back for a quick solution, and then it keeps happening, right? And then we pat ourselves on the back for becoming really good firefighters because now we know how to fix it every time. Versus the point of CAPA is to get the corrective action where it can't happen again. And that's difficult to understand. And so, yeah, if you're not seeing that in your suppliers, right? Sometimes it's you need to move beyond supplier management to supplier development, which is, hey, would you guys be open if we came in and provided you with some training on CAPA so that when you get a SCAR, you actually stand a better chance of producing a better result from that. Particularly if you're dealing with small suppliers and they don't have that kind of bandwidth, or it's just never occurred to them. So sometimes if it's impactful enough to you as the customer, that maybe it's you offer the resources to raise their game.
All right, great, thank you. What tools or methods do you recommend for developing robust preventative actions?
So yeah, preventive action, right? We were very focused, on corrective actions. And again, I always like to point out, in case you're not clear, corrective action is when you've already had the problem. Preventive action is when you can foresee the problem, but it hasn't happened yet, right? And so they are different processes, but the concept is the same. You've imagined that all right, this pipe might leak. All right, you use the same approach in tools and going, so how might that happen, right? It's a little more theoretical at this point, but the process is the same, the tools can be the same. Then you can do simulations and go, can we create a simulation where what we're thinking might happen would actually cause the pipe to leak? So it's a very similar approach, except right now you're kind of dealing a little bit more in the theoretical versus stuff that's already been observed. But it is a very similar process.
All right, thank you. Next question. We use the list of invalid root causes for reporting. Is there a list of valid root causes, or would you consider root causes something we can't categorize?
Um, yeah, I'm sometimes torn on this. Sometimes in less mature organizations, I prefer to limit their responses and tools by giving them pull downs and going, I want you to pick from this, right? Which means now they can't pick operator error because I'm not giving them that choice. On the other hand, if the organization, the environment is more complex, then I got to be careful of, can I actually come up with a list that's going to encompass all the possibilities? Because you always do, right? You could add, well, we have a miscellaneous or an other, right? And then you find out that that's what everybody clicks on. Right. Um, if you have a process for continuing to learn and grow that list, I think it could be a useful way to do it, to say these are the valid, root causes, and not give people the option to even pick the invalid ones. Just understand it's not going to be static. You're going to have a process by which you refine it over time. Continuous improvement.
All right, question. What's the best book you recommend on RCA? Um, or you do different engagements, Steve, as well. Can you help our
Um,
attendees?
yeah. Well, one I like, a lot of people are familiar with what's called the Memory Jogger 2. It's a book with all the quality tools, little handheld book that you can slip in your pocket. First, I always recommend that, right? If you're not familiar with what tools should be in your toolbox, that's the book you want. But similarly, there are other versions of those kind of pocket guides for things like FMEA, for root cause analysis. So I would buy them all, right? And build out your library, or essentially that becomes your toolbox. But there is a really good one by the same, group that's specific to root cause analysis. And I think they offer up a, very similar process to what I'm talking about here. And I think that's just a really good one and easy to follow. And that's what they design them for, is they fold nice and flat, so you can put it on a desk in front of you and pull ideas and methods out of there.
All right, great. A couple more questions. What do you think of the Apollo root cause analysis? It provides tools, methods for a reverse engineering approach to a strong problem statement, since it's wise to use multiple tools.
So I have to admit, I'm not familiar with the Apollo root cause. I'm assuming that comes out of the Apollo program, would be my guess, right? Something that NASA did. In terms of reverse engineering, um, it gets to what I was talking about, getting a good problem statement and investigating things to shore up that you've got the right problem statement. So I think that's kind of the same thing. Is, yeah, part of it could be, yeah, let's reverse engineer our theory. If we think this is the problem, then let's go backwards from that and go, can we get where we think we're going to go? So I think it's a similar, it sounds like a similar approach to what I was talking about here. I'd have to read up more about specifically what's going on with that. But was there a second part to that question? It scrolled by and now I don't see.
No, yeah, just
There
because
it is.
you mentioned it was wise to utilize multiple processes or tools for
Oh,
RCA.
somebody just, yeah, they were
Yeah,
just agreeing. Yeah, right.
yeah.
Yeah. Can't have just the hammer. Don't make everything look like a nail. Maslow was
Um,
right.
Next question. If just starting this process at a company, what is the best way to get everybody on board?
I think general education, right? Let's, make sure everybody understands the terminology here, right? What is the difference between a correction and a corrective action and a preventive action? I saw earlier in the chat, they went by, somebody talked about containment and mitigation. Yeah, what do those look like? I think if everybody learns to speak the language first, then that kind of drives the thinking on this. And then start talking about things like apparent cause versus root cause. So I'm always big on, give them the context, the why. Then we can say, all right, now that you understand the background, the foundation, now I can show you the process, and it'll make more sense, right, on how to do that process well.
All right, great. In a very manual process, sometimes it really is the operator's fault. How can you go beyond operator error in this case?
So again, I'm always hesitant to blame the operator. I'm going to want to ask questions, right? If the operator just wasn't competent, they didn't do the job right. All right, then I want to first look at a bunch of other things, right? Were they trained appropriately, right? Is there effective training? Is it just something that's so hard to do? Of course it can be, right? But if it's, you do narrow it down, it goes, it's only that operator. we feel like the process is really effective, which is evidenced by the other operators can do it, consistently, then yeah, maybe you just have the wrong person in the wrong seat. That's always a possibility. But I don't want you to just knee jerk go right to the operator, right? You should eliminate the process issues first. Beyond that, it's oh, sorry, I lost my train of thought there. Um, and it scrolled by. I'm sorry, can you read the
Yep.
question to me again? I
Yeah, I
had a
can.
bunch of different things and
Sure thing.
yeah.
Let's see
Oh, it was
here.
about, okay, it's about it
Yeah.
being a manual process. Again, okay, so I was gonna say is, and then the other question I always ask is, why is the operator able to make the mistake, right? If it's that important that they have to do it a certain way and get a certain result, I'll want to ask that question, get back to the process. Why is it possible they could do it? Sometimes I've had people say, what if they did it intentionally? Okay, well, then I'm going to say, then why does the process allow them to do that? If that was important, you should have figured that out when you were designing the process and doing your validation and go, what prevent protection should we have put in there so that somebody can't turn the dial on the machine because they think it's funny, or they're on their last day and they're going to walk by a machine and start changing all the dials. So you have to get first, don't automatically blame the operator. What else is going on before I get down to, you know what, maybe we do have the wrong person in the wrong position here.
All right. And then just finally, I think maybe some audio might have cut out. What was the name of the book recommendation that you had made?
The main one you can look up is the Memory Jogger 2, available on Amazon for like 19 bucks. I can pull out the other one real quick. We got a second here. Give you the
Thank
title
you.
of the root cause one because I
And I did want
carry
to,
it with
while you
me.
do that, I wanted to acknowledge to everybody who had requested a demo. We will be reaching out. So thank you for that.
Okay, so there's all my books. I carry them with me. And oh, this one actually came from ASQ. That going to show up? Sort of. Okay. So there's the book, the ASQ Pocket Guide to Root Cause Analysis. But it looks like in the Memory Jogger 2 was this one. I gotta get the reflection off here. So get that past my microphone. So, and like I said, there's all kinds of ones here. Which one did I pull out here? FMEA, risk-based thinking. There's a good one. So these are great. They're easy to carry around and they're cheap and they have great information in
Great. Maybe we can do a link to your favorite books post on
them. Yeah, I should
LinkedIn.
probably do something
That'd
like
be
that.
great.
Yeah.
All right. Well, thank you everyone for attending. Again, thank you so much, Steve, for your always enlightening presentations and very engaging. We always have tons of questions for you. Don't forget to register for next month's webinar and innovate if you want to hear Steve speak again. Thanks, everybody.
Thank you.